Ohm's law. Before we attempt to understand what exactly is Ohm's law, let's go back to the water analogy that we did earlier. To get some more insights into the relationship between potential difference and current, let's say we have a closed loop of pipe fully filled with water and having a water pump inside it. When we switch on the pump, it forces the water to circulate either clockwise or anti-clockwise. If we were to increase the pressure of the pump, the rate of flow would increase and vice versa. If the pipe is clean and smooth inside, there will be almost no opposition to the flow of water. But if the pipe is dirty or rough on the inside, the opposition to the flow of water will increase. The pump must perform some work to overcome this opposition, and as a result, the pump cannot circulate as much water per second as it did before. Thus, the rate of flow decreases with an increase in the opposition to the flow of water. If we were to block the pipe anywhere along the path of flow, the pump would no longer be able to circulate water no matter how high the pressure. The water pipe analogy is very useful in understanding the concept of resistance in electrical circuits. Please remember, the flow of charges in conductors is never smooth. The electrons undergo millions of collisions every second with the crystal structure of the conductor. And in these collisions, some of the energy is dissipated as waste heat. The opposition provided by the conductor to the flow of electrons inside it is known as electrical resistance. The lower the resistance of a material, the better a conductor it will be. Materials with high resistance are known as insulators. They support almost no current. Georg Simon Ohm was a German physicist who discovered a very useful relationship between resistance, potential difference, and electrical current. He found that for a certain class of conductors, which is metals, the relationship between potential difference and the corresponding current in the circuit was linear, which means that the graph of the voltage versus current was a straight line. Also, the slope of the graph between voltage and current for such materials was constant. In such circuits, V or voltage is directly proportional to I or current. So putting the constant of proportionality into this expression, we get a new expression, V is equal to R multiplied by I. And this is the mathematical representation of Ohm's law. The unit of electrical resistance ohm is denoted by the Greek letter capital omega. Mathematically, 1 ohm is equal to 1 volt divided by 1 ampere. Conductors having a relatively high amount of resistance are called resistors and are used in circuits to control the amount of current in them. Let us understand this concept a bit more using a simple numerical problem. Let us say that we have a circuit composed of a conductor whose resistance is 10 ohms. We apply a potential difference of 20 volts across this conductor using a battery. What is the current in this circuit? Well, if we look at the expression of Ohm's law, V is equal to IR. It stands to reason that we can transpose R to the other side of the equation, which means that V upon R is equal to I. Since the value of voltage or potential difference is 20 volts and the value of the electrical resistance is 10 ohms, the ratio of the voltage to resistance is equal to 2 and the current in this circuit is 2 amperes.